Okay, so welcome again. This is the Signal Worked examples session, and we're going to look at a couple of example experiments, perhaps the pitfalls that you might encounter, and hopefully some tips and tricks to make it a little simpler to operate. Okay, so the first thing we've got to consider for any of these experiments is Signal requires a trigger to capture a sweep of data. So we need to decide what type of trigger that is. For many of you doing TMS work, then you'd have a mix of triggers. That is, you may be looking at hotspotting to begin with, and that means generally that we have a trigger coming from the stimulator, and that's fed into the trigger port of the 1401. Once we move on from the hotspotting, you could then generate multiple states with multiple states of output with different intensities, different numbers of pulses, etc. So we are then triggering the magstim. And so the trigger for magstim magnetic stimulator. So the trigger for Signal is actually then time. We have an internal trigger generated at a fixed time interval, or perhaps at a random interval. But there are other types as well. Just so we know, I'm running Signal 706 here, which I'm absolutely promised for definite this time, that it will be out in the next week or so. Okay, so onto our sampling configuration window and into the general tab. What type of trigger? An external trigger coming into a Signal, we would tend to use peri trigger. If we were sending out triggers, we would tend to use fixed interval fixed interval. Thinking of TMS once more. An incoming trigger could also feed the basic mode of data capture. And we have, there's other flavors of these types here with fast triggers, fast fixed interval. So fast triggers, we may have something like a nerve stimulator to the throat here, triggering at 50 times a second. They're very fast compared to TMS again, or other evoked response recordings. Now, I'm talking of TMS quite a lot because the majority of people tend to be using Signal for that, but we do have many people using Signal for patching as well. In that mode, we tend to be sending out the triggers, that is a waveform to stimulate the cell. And we use time, an internal clock inside the 1401 to act as the sweep trigger. Okay, finally, we have a gap-free mode, which is, again, internally timed, but we start off the acquisition, one sweep of data capture is performed, and then immediately another one starts. So there is no lost data between each one of these sweeps or pages, if you imagine it as a book. Right. Now, thinking of triggers from other devices, it's essential that you know which edge of a TTL pulse, a trigger pulse, is being used by that device. We don't want to trigger on the wrong edge and be, say, a millisecond out. We don't want to be 50 milliseconds out. So you might want to change the state, the edge trigger that you're using. Right. So with peri-trigger mode, we have other types of triggering as well. So instead of a TTL pulse, a digital pulse, we can record an analog signal into one of the ADC ports of the 1401 and then respond to it. That is, trigger a sweep of data capture when a signal goes above a level, below a level, or at a positive and negative level. So it has deviated one way or the other. And that's in addition to our TTL input, as well as digital markers. That is a separate computer sending over messages to us on the lower bits of the 1401. That would then cause a sweep. of data capture as well. Right, I'm just going to have a very quick read of the chats just to see whether we're going to be sent in any particular direction. So the first one is, hi, I have a quite specific question. I'm doing measurements in one channel, electroretinogram, light stimulus. I performed 6 measurements where the first 3 and the last 3 are different. Is it possible to take an average from the first 3 and the last 3? So are you saying there, Sane, that you have 3 sweeps of one type and 3 sweeps of another? Okay, please get back to me on that, because I think that's just a matter of the different states that we would use. And Lazani, I do in vivo wholesale recordings using Signal, predominantly current clamp. Would it please be possible to share scripts on offline analysis and membrane test, action potentials if you have an existing ones? Certainly will. I have at least one script that I can think of right now for the action potentials, and I can send that to you, and we can have a look at it a little later in this session. Okay, so I'll ask you to get back to me, please, about the different measurements, and we can tackle that in a few moments. Right, where were we? So triggering. So we've decided what type of trigger we have. We're using a magnetic stimulator. We are doing hot spotting, peri-trigger mode. The trigger is coming in from outside and connecting to the 41 trigger input. Moving on to such things as seeky-licky type experiments, then we are sending generally we're sending triggers out to the stimulator, and therefore we would go into fixed interval mode. Let's just go to fixed interval. Okay. Now, with some of these modes, we are able to include multiple states, and in some, this is not available to us. For example, gap-free, we don't really have a good enough reference point, a 0 position around which we could set up our pulses. And those pulses that we normally set up are in the multiple frame states area. And we'll look in detail at that in a minute. Okay, so we're pretty much fixed on peri-trigger and fixed interval modes. But as I say, the more exotic ones, the fast triggers and fast fixed intervals can be quite useful at times. Right, so the next step, we need to decide on the sample rates. So I would think in Signal, people tend to record at a few kilohertz to say a few tens of kilohertz, but not that much more. Although we have had people in the past looking at recording a pattern of DNA of all things, and they wanted to record at 2.5 megahertz. Now, I'm going to the sample rate because for some of you with older equipment, you may find that you run out of memory space. That is, Signal locks down an area of memory inside of the 41 sufficient to capture the sweep of data for the length of time that you've asked for at the sample rate that you've set. If with the older 41 pluses, the older micros with about 1 megabyte of data, then it's fairly easy with long sweeps and faster sample rates to exceed that limit. Okay, not so much of an issue now with some devices like the Power 41 with its 1 gigabyte of memory, of which we can use most of it, or the Micro 4 now with its 4 megs. Okay, so at the sample rate, let's pick something in the middle, 5,000 hertz, frame length around a second, frame points is automatically calculated for us, and importantly, we should remember to set the x-axis offset for a lot of experiments. So where is this 0 trigger pulse going out of the 41 if we're working in a fixed interval mode? So we normally align the pulse, the first pulse going out to the stimulator with the 0 using this x-axis offset. So if I were 200 milliseconds into the sweep, when I produce the pulse, I'd like to align 0 to that. Now I'm using milliseconds here. For those of you who are seeing seconds, you could go to the edit pull down in preferences, and from there you can specify whether you want to see microseconds, milliseconds, or seconds as your default. Okay, right. Now, finally, we come to the ADC ports. Now, I've listed 0.2, so 0 to 2 inclusive. If we were working in peri-trigger mode, and I had 1.3, for example, so that's 1 to 3 inclusive, but then added 0 at the end, that 0 channel, port 0, is the one that would be used for any analog peri-triggering. So always the last port in the list is the channel, there's the channel used when triggering off an analog waveform. Okay, let's go back, switch this to fixed interval. Right, over on the right, we have the keyboard channel. I've mentioned this before, that I think it's not very useful most of the time in Signal, because the sweeps are very short and you have very little time to put anything down by hand. But one extra channel in the marker section here that is quite important, quite useful, is the digital channel. And I say that because I see so many people recording the TTL pulses that are going out of the 14.1 back in as an analog signal, which is rather costly in terms of space and remembering that memory that we might chew up inside the 14.1. So a digital marker can be written to from the sequencer. Now the sequencer is where we generate all of our pulses. So if we put a marker at the time of the TTL going out, then it's automatically recorded into the frame that we capture, into the sweep that we capture. Okay, now I could go into much more detail on the sampling side, of course, but we did a session a little while back, so I think we can afford to skip some of the finer points here. I have had a bit of a feedback about the two different types of output. That is, it was a light stimulus where we performed 6 measurements where the first 3 and the last 3 are different. Now, I'm assuming at the moment that we could treat these as 2 different states, okay, as opposed to 6 triggers or outputs within one frame. But I think we can afford to look at both. Right, from the general tab then, we can go to the states tab if multiple states is enabled. So here we go, states, and we're going to say how many states we've got. Now I'll throw in 3 rather than the 2 that we've seen in the chat. And now I can decide on how these are ordered. So are they simply numeric? State 2 follows state 1, state 3 follows state 2, or are they picked up randomly or set into a protocol? So 3 states there. I can then randomize to a degree the number of repeats we were getting as well. So if I were to say for state 1, I only want this to appear once in my set or cycle, then here is where I'd set individual repeats. Now I'll switch that off for the moment and allow this to run, but this time with a device we haven't seen before, and that is a DS8R. So I've added a device, DS8R, here it is. Use this device, I've provided it with a serial number, and then for the different states here, I've got 2 milliamps, 200 milliamps, and 400 milliamps. And I can also state whether there, positive, negative, well, monophasic, biphasic, etc. Okay, so let's just run through that. I've set the minimum time there to 50 microseconds per pulse. Now, for any of these auxiliary devices, devices that we can connect to through software, we can test test the communication. Everything looks good. I'm going to disable state 0 because I feel that we need a state to go back to as an idle state. So nothing is happening. We're not sending any pulses. It's purely for monitoring. And now we can say OK to that. I'll just do a couple of quick checks here. Make sure we haven't done anything daft. And let's change this to just port 0. Extended fixed mode cannot be used with outputs disabled. Time, disable outputs. Right, outputs. Okay, so sorry, I didn't include any outputs at the moment. All I want to do is show you some changes on the screen here. So this is the DS8R. Okay, hopefully the light doesn't affect the screen too much. So we have electrical output to the subject here. We've got a manual trigger, I believe that is, manual trigger in the center there to fire it off. And over here it's all mirrored. Over here we have a display showing us the current, at the time output, 2 milliamps. So if I start the recording now, we're in basic mode, so we shouldn't see any change. But if I now cycle, we should start seeing, yes, 200, 400, 2 milliamps. Okay, there we go. So it's just cycling around in, if I believe I said it correctly, a random order there. And that's the DS8 changing values. Okay, so we'll stop that for the moment. Now on the back here, we have a trigger input. Now that means, like any other of the other stimulators that we deal with, we wish to provide a trigger at a very accurately timed position in terms of reporting one, after setting the stimulator to present a certain intensity, or in this case, constant current output. On this device too, we have a control line, a BNC, which accepts a waveform input. And I think this says that we have 10 volts per amp. So if we provided a 5 volt output from the 14.1 to this device, we would get 500 milliamps. Okay, and if we wanted to use this device to trigger a signal, that is a TTL pulse going into the trigger input, we would have an output from here, which is labeled sync in this case. So this is quite a versatile device in terms of allowing us to trigger it, or it to trigger us. Okay, bear with me just a second. Okay, right. I've just been asked, can you please clarify what you mean by connecting to sequencer to get the digital marker? Do you mean to add a digital marker in the output pulse config window? Yes, almost precisely that. So let's finish the recording here, close that down, and now go to the sampling configuration. We've only looked at the auxiliary states at the moment to see changes. We haven't done anything about triggering. So here I've got a digital output, which is much more robust than using a 5 volt output from the DAC to trigger any stimulator. So generally we use DACs to change the state of a device rather than to trigger it. So there's not a lot of drive on the DACs, but there is quite a bit on the digital side. So let's configure the pulses now, and let's go to state 1. Now we can stretch the window open here and just realize that a change that we've just made to Spike 2 could come over to Signal here, where we can change the background colors to make it easier to see what's going on. Now, we can't yet edit the labels for these channels, as far as I know. Okay, but that's coming soon. So digital output. Let's put a pulse here. We'll put another one on the analog side and set it to 5 volts. So now I'm taking the marker flag from the palette, and I'm placing it at the time of the leading edge of the pulse, because that is what is triggering my external device. Now I can change the code here to be 01, and I can set another code here, say 02. So that's state 1. I've got a minor timing fault there. So that's 380. That's 380. That should be all right. We'll kick that off. Let's just set this back to avoid embarrassment just for a moment to 279. And I've got to think about which happens first, whether it's the analog output or the marker that will occur first. Right, so state 1 had the markers, so we run now. Start, we're on basic. I'll pause at the end when we have state 1. There we go. Oh, where are they? Let's just check that I've got the right sweep length here. Outputs, configure pulses. State 1, digital. That's right, I've got a second sweep. And in general, I've got a second. That should work, and I've got digital enabled. So I should be seeing now digital markers appearing on the bottom channel here. I'll just move this up to the top. And we start. Go to state 1. There we go. So I may not have hit on state 1 immediately. So those markers are a good representation of, or they are marking when the pulses were sent out. It saves a lot of connection of outputs back to inputs on the 1401. And remember that Signal is predominantly waveforms, not event data as well. That's really the Spike 2's domain. Okay, so I hope that answers your question about the markers there. Right, let's close this down and get back to the sampling configuration. Right, so as part of setting up for this experiment, we need to do some work on the ports. So to calibrate, for one, what the input really means. So had we got such an amplifier as a 1902 from us, then quick calibration would change to CV 1902. We have the Digitimer D360. Soon we hope to have the D360R, which is a 4-channel version of the 8-channel D360. There's the 440 and a handful of others. Now, all of those are software controlled. If we make any changes to the amplifier's gain, then that's reflected in the scaling that we would see in Signal. For a lot of channels, though, we don't have that luxury. So we might put in a quick calibration. So I'll just edit this. So we have 10 volts at the input, and that's labeled as volts. We say OK. And now I go quick calibration. And here we can specify how we want to see the data, so, or the y-axis. So I want to see microvolts, and we have a total amplifier gain of, say, 20,000. There we go. So it has calculated for us the full scale value correct for the gain applied. Now, we're not doing anything about any offset there. So that's a bit of a problem. We would need to input that, if there is an offset, at this point here by double-clicking on the port. Right. Now, some people doing clamping would need to come to this tab. Some of you may not see that because it could be disabled as part of the preferences, enabled and disabled as part of the preferences. But from here, we can specify what type of clamping we're doing, single channels or wholesale current or voltage clamping. Okay. Now, as you've seen before, I'm sure, the channels here are showing up, titles are showing up in red, indicating that the units are probably wrong for the setup we're asking for. Okay, so I can go and modify all that to get it correct, but I think I'll switch out of clamping for the moment. Another device we can connect to through software, though, the Axon molecular device is MC700. So this would allow us to read and set various parameters during our session. Okay, so the outputs, we briefly looked at this a moment ago. And I think I'm going to loop back to triggers. We mentioned triggers coming in, as in digital triggers into the TTL, transistor logic, into the trigger input of the 1401. Output triggers from the 1401. So we're basically treating, we're using time as the trigger for the sweeps when we're driving this from the 1401. We've got those digital markers that could be coming into the rear panel of the 1401. And we have the analog inputs where we could trigger a sweep based on the waveform going above, below, or above, or either direction in peri-trigger mode. But if we were to use a sequence, we could also get another type of trigger. So let's just write ourselves an example sequence here where we might have something trig. So that will trigger a sweep. So perhaps we would do something before that where we're looking at a channel, we're filling a variable with the values found on channel 1. We make some sort of comparison, branch of greater than, and we've got, say, a V2 as the target and V1 as the reference, their current data point, and we loop back if it is not right. So if we are greater than, we're going to loop back to A and keep going round until we go below a level, and then it drops through and we trigger a sweep. So not only have we got these digital outputs, we've got digital inputs, we've got time as a trigger, but now we've got the sequence, which can be set to free run, monitoring incoming data, and perhaps trigger a sweep when conditions are met. Okay, now I'm not going to run that version because that was purely an example, but to make it a bit larger on the screen, that's roughly what we would need. Now, if we were using a sequence or the pulses output, we've got to think now about the resolution of those sequences. So how quickly we execute each of the commands that make up the sequence. So what you see in the pulses output, the dragging of palette icons onto the output tracks, generates some code in the end. And each of the commands take, at the moment, 1 millisecond to execute. So imagine now that you wanted 2 pulses going up on 2 separate lines, like so. And we configure this in, say, state 2. We have digital output 0, and that's at 270 milliseconds. We set the second one at 270. I can only get to 271 milliseconds. That's 1 millisecond resolution, limiting me to 1 millisecond steps. If I now come away from that and go a little faster, 0.1 millisecond resolution, configure the same pulses. And this time you'll see I can go to 270.1 milliseconds. Okay, so 2 pulses going out, say a paired pulse experiment, and you wanted 5.5 millisecond separation between those pulses. You'll need to address the resolution question to achieve what you need. Okay, so that's that. All 1401s have 16 digital inputs and 16 digital outputs. Generally, the ones that we're using here are the upper 8. So the outputs on the front panel that you see, and those duplicated, and the other 6 available on the rear panel of the micros and the Power 1401s. With a micro, until recently, there were only 2 analog outputs as well, but now there's a build option to have 4. Powers, on the other hand, have 4 on the baseboard and can be expanded to 6 or 8 outputs. Okay, so the next question, we've looked at the types of triggering we might need for the experiment. We've looked at setting up the ports. We've decided to set up some pulse outputs, but can the pulses be generated all through the sequencer, text sequencer, or through the screen like so? So if we wanted to produce some weird and wacky waveform, which we put another pulse into here, it's a very short length and it has a size of 3. If we wanted to do something a little more with that, perhaps smoothing the sides here, we'll find it very, very difficult to do that within the graphical sequencer. So we might instead use the arbitrary waveform option here, dragging up onto the blue tram line at the bottom of the screen, and now pasting a waveform there. Now the waveform can come from anything previously recorded, perhaps something you've imported, and also something that we've generated. So within a data view, an empty data view, we could create what are called virtual channels. We could provide expressions to that virtual channel to perhaps provide a sign. Create a second virtual channel of a sign at a different rate, and then a third virtual channel to bring the 2 together. So something that could then be pasted into this window. Another question to ask is how much or where do we want all these outputs to happen? Now we've looked at the blue tram line at the bottom, and we've got pulses all within that darker blue area. So that's the sweep, that's the captured area within this outputs frame. Now let's change that position and now update these pulses, roughly speaking, like so. Okay, so this means that I can provide pulses outside of the recorded area, both before and after the sweep. So we might have conditioning pulses before, and then something that perhaps pulses every second, every 5 seconds, until we capture another sweep of data. So that the trigger in terms of this part of the experiment is time inside of the 1401. And we know that the output here is starting at, what did we say, 500 milliseconds before the sweep is due. Okay, right, so that's got us a little further into the output side of things. Let's go now to the states. Now, we've already talked about there being different pulses per state. So when we're thinking, again, back to the electroretinogram, we're performing 6 measurements where the first 3 and the last 3 are different. So in our states tab, we could have say, a longer duration strobe on for 3 different states. So we might start at, I'm guessing at tens of milliseconds. The next one could be 100 milliseconds. We could burn the retina with a strobe that's on for a full second. Each one of those outputs is different. Okay. When we're recording, the waveform data in the sweep is accompanied by the state used at that time. So that means when we come to analysis, we could say, okay, I want to analyze all those frames that had a state or strobe on for the 100 milliseconds. And so we'd say it was state 2, that was the one that delivered 100 millisecond output. Give me all of those and perhaps an average from them. Right. Now, another type that we could look at is outputs here, configuring the pulses again. I'll find something empty again. Let's say you're ramping up. So taking on the idea that we have, yeah, let's do it this way. Let's have 1 at 1, 1.5, 2.5, 4, and 5. So in this case, what I'm describing is an output or a set of outputs, set of triggers, stimuli for this one state, but I'm triggering this strobe at different intensities. So we've got a low light intensity here and a high output with this one. So how would we deal with that? Well, we could capture the frame perfectly fine. We know that the strobe are fired, but I think it would be very handy to have those markers in place again to identify quickly which of these pulses happened when. If we don't use the marker, we could, of course, record back in the analog output and use that as a reference when taking the measurements. We could, if using the waveform or the digital markers, then step through the frame using cursor 0. Now that cursor 0 could, on the waveform, find a transition just above 0. So let's say we've got a safety 0.1 volts in this case, above baseline, that we can trigger on the rising edge. Cursor 0 can then latch to each one of these. Cursors 1 and 2 could then jump into a range around it, say the next 20 milliseconds, we're expecting some sort of response, and take the measurement and put it into an XY view. Likewise, if we had the markers for each of these pulses, cursor 0 could jump to each one. Again, once cursor 0 moves, it is the iterator. Other cursors are told to update their position. Okay, I think we could look at that sort of thing happening in a short while here. Right, so states. Signal is generally about the trigger, sweep of capture, and what is happening during that sweep of capture. So what is the output that we wish, if any, that we wish to produce, and how are we ordering them? So I've touched on this already. Have we got a set protocol that we want to send out pulses in a very fixed order, completely repeatable? Or can we afford to have it random or in a semi-random form, so random without replace? Should we also have the individual repeats? So we're skewing the number of presentations for each of these states of output. Okay, so all things to think about. I think it's important to remind you that we can add multiple auxiliary devices to the list as well. So if we add in, say, power mags, mag and more device to a mag stim and to a DS8R. Now we've got two stimulators, two magnetic stimulators and a constant current stimulator, all being controlled at the same time. Doesn't necessarily mean they're all going to fire within the same sweep. We could separate them out so that there is one state dedicated to constant current, one's dedicated to the mag stim, and one dedicated to the power mag. Okay, and all right, finally, we'll get to the do automate stage. So you may find that you're running multiple recordings in a session. So you might give a name and simply 00 would allow you to increment that file name every time that you open as you start a new recording. You can also add in the date formats to this. You can specify the total number of frames that you're going to capture. So if you've got a very fixed regime there, we can work out how many frames are necessary to be captured, and sampling will stop once we achieve 20 frames. Now, we know that things go wrong, and that if one or two of the frames sweeps were not captured because the subject wasn't alert, the electrical or magnetic stimulation didn't happen in the right place, we can repeat some of those missing states. Okay, I don't think really the others are of that much interest. I mean, it used to be that a file size limit for putting data onto a floppy disk. I mean, these days, your USB drive on your keyring has far more memory on board. Okay, but one thing to mention here, artifact rejection. We can tag or throw away frames. Tagging simply means to mark it. Reject frames is to remove it from the file. If data points, a percentage of data points go above or below a level as a percentage of the total ADC range. So I'm dealing with a 10-volt system at the moment. Usually people have a plus and minus 5-volt system. So if a stimulus artifact came up and stayed high or caused a ripple, very large ripple, we could then say, right, that really would have ruined our response, viewing of the response. So tag it or throw that frame away. Now that's not quite the same as using an artifact clamp. So we have devices like the 1902 amplifier from us, which have a circuit on board, which effectively blanks the incoming signal just prior to the stimulus being fired. Now that means that the amplifier is then unblanked, unclamped, effectively rejoining the wires again moments after the stimulus has gone off, and that prevents the amplifier from being hit by a very large signal and causing it to be unbalanced. Right, so okay, there's that. And finally, I think output resets. This was added a little while ago now, but it was some time coming. It makes sure that the 1401 is set at the end, at the beginning of sampling to a known state. Otherwise, you could, if you stopped sampling, leave the 1401 in an unknown state, meaning that some pulses could be still set high. And when we start recording and pulses are set back low, this could cause a stimulus to fire, which could be, at the very least, uncomfortable. Okay, so that's that. Right, I think we better have a look at a little bit of that analysis. So let's just take this off. Let's get rid of that. We aren't clamping states. Yeah. Okay, so let's run this now. Okay, and I want state 3 really. Okay, so let's just connect the analog outputs to the analog input. That's DAC 0 back to ADC 0. Now, home and end give you an optimize and zoom out, that is, zoom out to the full range of the ADC. Let's just stop this for a moment, or to pause at sweep end. Okay. Now, a couple of things to talk about here. You see, since I've added all of those auxiliary devices, I now have these settings toolbars. So it's possible to control TMS devices using that RMT percentage. And it's certainly possible to get in to each one of the configuration boxes and change outputs. So this time I want to go to 100% and say MSO, so the device power, or set this to RMT, where you can see the value has jumped to 333. So all of these allow you online control of the stimulators. If I had one, then we could control also the signal condition at the 1902, the D440, etc. Okay, right, so that's a bit of background on the screen there. Now we have our 5 pulses. I know you said perform 6 measurements. The first 3 and the last 3 are different. Well, I have 5 and they're all different. So what could I do? I could set up cursor 0 here. Forgive the label, but I'll show you how to change that. Right-clicking on my cursor, I'm after active mode. I'm going to set the label here. And where's that gone? It's gone to another screen, hasn't it? Because I was using this in dual screen mode before. Okay. So OK to that. Right-click, set label. Okay, that must be off screen, so I apologize. Anyway, we can ask for the cursor to have its number, its position, amplitude of a waveform, or something labeled just like I have it here, where I put my own text in. Anyway, it's the active mode I'm after. And so for this data with no markers for each pulse, I'm going to say rising threshold on channel 1, where I'm going to set, say, the equivalent of 0.1 volts. So let's say 10 on this scale, 10, yes. Start search min time to be sure, and max time, threshold level 10. Now, the difference between X low, X high, and min time and max time is X low is the visible range. So if you've zoomed into tens of milliseconds, then X low will be the lowest value we see on the X-axis, and X high will, of course, be the highest value. Min time and max time are the extremes of the frame or sweep of data. Okay, now I'm going to leave the rest alone just to see whether this works correctly. So I'm using Control-Shift and now moving through those different outputs. And I've managed to jump to each one without a problem. Now, if this data were noisier, then I might check a little bit more of the active mode and look at some noise rejection or delay after crossing. Delay after crossing is really very useful when we're looking at, say, silent period. So we're searching in a very blank area of the record, and we're searching then for the first time that we see the EMG coming back into the signal. Now, we may get early EMG activity where we might have 1 or 2 data points that go above our thresholds. Now, that to some people isn't enough. We want to see solid, robust EMG activity. And so we can say there must be 5 milliseconds or so of waveform going above a level for it to be a valid point. Setting to 0, and we would find the very first data that rises or falls below a threshold. Okay, minimum step here is a way of saying, okay, now I've found this position, I will step by n number of milliseconds before searching again. So if all of these pulses were exactly the same length, which they appear to be, they're 100 milliseconds, and I can double check that. by Control-Alt drag, so 100 milliseconds. You could also see the amplitude, so 74.1 microvolts roughly that I'm measuring there. Then the values like that could be added to active mode, and I can say jump by 110 milliseconds, therefore avoiding any possible chance of finding another rising threshold in this area. That's assuming that the data was fairly dirty, had a lot of noise on it. Okay, so now we've got this channel, this cursor moving like so. We want to get some output. Where does this output want to go? Should it be to an XY view, or should we put it to the data channel area? So here we have the measurement functions, XY view, trend plot. Trend plot is generally what you'll want to use because that's taking one measurement per frame. That's one measurement per channel in the trend plot that you've created. An XY view, on the other hand, can take multiple measurements for one frame. So that could be very useful for what we want to do now with cursor 0. Or, as I mentioned before, the data channel. If I ask for a data channel, the dialogues are really quite similar between this and the XY view. The upper section here detailing what cursor 0 has been asked to do. And then bottom left, the X measurement, which might be, it was going to be time in this case, and we're going to use cursor 0 as that, versus, say, the mean of our waveform channel and start time and end time. So if we specify cursor 0 plus 10 milliseconds to cursor 0 plus 50 milliseconds, and say new and process. Okay, we should now have a new channel, M1. Why isn't that? Why didn't that give me any data? Okay. So I may have got things wrong here, where I'm expecting cursor 0 to move between these points, which it does. And for my memory channel, process settings, right-click process settings, I'm specifying everything correctly here as far as I know. It's the mean of the source channel and the start time and end time. That's milliseconds, so that should be right. At least I should be getting some output here. Okay, now I'm fearing that the values have not been translated properly. And I was hoping to show you that you don't always need to use extra cursors for this output. But I think I'm going to change my mind now. I'm going to add 2 cursors to this output, to the measurements. This one, cursor 1, I'm going to set to active mode, and that's going to be an expression. And that expression is going to be cursor 0 plus, I think I said 10 milliseconds. Okay, so cursor 0 moves. Cursor 1 is always 10 milliseconds away from it. So for sanity, I've checked that my measurement value is correct, 10 milliseconds on from cursor 0. And likewise, cursor 2 is going to be set to expression. And that, again, cursor 0 plus 50 milliseconds. There we go. So that all looks correct. So if I now go back to my channel here and I set, where are I? Did I click on the wrong one? Channel M2, process settings. I'm going to change from the time, which should have worked, to 2 cursor positions. Now, I don't see anything wrong with this output otherwise. And process all filed frames. We have been writing to disk. All filed means written to disk, as opposed to sampled frames. So we may not actually store them, we just want to sample them and view them briefly. Or tagged or untagged frames. You remember we talked about tagging as part of the artifact rejection. Okay, so all frames there, and optimize. Leeway for processing, we don't need to. Right. So all file frames. And I think what I'm going to get is just stop this and finish. Because I think it's because I was on frame 0, which should allow me to update, but let's process. There we go. Right. So it's my mistake. I missed something in the outputs, in the setup there while sampling. Now you can see I'm getting a measurement per section here. Now, I'm a little bit concerned that we're not seeing one at the first pulse. Okay, and yes, not quite where I'd want to be with this. Anyway, if we took that, put it here, lock the axes, and draw. There we go. So that's the position of the measurement and the mean value at each one. So I must have made a mistake not being able to find this position here. So I really hadn't set cursor 0 to go to the absolute minimum time to start its search. But hopefully that gives you some idea there. Right. Okay. Now there's a lot we can do with the measurement functions. Let's go, just open something here. Where are we? Documents. And signal data actions. Okay, so you've seen something like this before where we're plotting the amplitude of these action potentials. Okay, so what else could we do with a trend plot or an XY view? Remembering an XY view or data channel can take multiple measurements per frame. You'll see here that the trend plot is limited. It's more limited in that it's not using cursor 0 iterating through a frame. We're simply saying here, find a feature and then take a measurement, where the X measurement could be anything from power of the magnetic stimulator through to the frame number, through to the absolute time of the frame, so time of day of the frame, versus the same list on the right. Now we can keep adding channels to this. So without setting anything up, I'm adding say a mean, this one peak to peak, etc., and keep going like so. As soon as we're not going to get anything out of this, but as soon as we say new, we get a trend plot ready to process the offline or online data. Okay. Other useful functions, the info windows. Now, quite useful when it comes to an XY view to tell you whether the response you're getting now is greater or less than the previous. If an info window is attached instead to a data view, it could give us information about timing, as an example. So we could be sitting there with the coil or the stimulator attached to the subject, manually triggering it, monitoring a timer set up in this window. let's take that away and just put in a timer reading and apply. There we go. So we can limit this to just whole seconds, etc., to make it a lot tidier. And when a new sweep occurs, then this would be reset each time. Okay, so something useful there. All right. I promised to talk about action potentials here, so let's go and find a little script. Right, 7, is it in here? No, so it's got to be in here. I don't think I've moved it very far. Okay, so this is something I'm just currently working on changing over to Spike 2 as well. Here's the data file we were just looking at. The script now running is asking me to choose the channel to analyze. Now, this could be anything. It doesn't have to be action potential or something. With thinking of any script, and could be fully customized by you, saying, okay, I want channel 2, but I want to reference another channel or a process channel, something that perhaps might be, say, a virtual channel of rectified and smoothed EMG activity. Check individual spikes, that's fine. We say okay to that. And now we're setting a threshold. So this is simply to say, okay, a spike, an action potential, is something that has gone above this level. Okay, and we can see that that doesn't differ too much, I say, throughout the recording here. We say okay, and the script has moved through and found, using cursor 0, the first event, action potential, that has gone above the level, and it's found the peak for that. Other cursors have then been set up to find 10% and 90% rise, the 50% position indicated by these two cursors here, and then where we've fully repolarized here. Now, with those cursors in position, perhaps you might want to modify manually those positions, and remember you can do that with the XY views as well. We can go on to next, to next, to next, to check, and allow it to finish off by free running. And here now we have an output, which is the frame number, the spike number, so how many spikes were found within the frame, the time of the first spike, and then the second spike, the third spike, etc. Threshold amplitude, 10 to 90% rise, half width, etc. So this was perhaps written for a user many, many years ago. It's been widely used since. And the output is in a form they could take straight to another package and analyze it further. Other scripts, batch processing. So take the script I've just shown you and put it effectively within a batch processing script. So a batch processing script would ask you to open a folder or identify a folder. The script, the batch script, would then read the names of each of the data files within that folder, and then open each one in turn. As it opens each data file, it will execute the rest of the script, which is this action potential program, hopefully with little or no interaction from you. Once the analysis is complete, it will close the data file, store away the text file it's produced, and then repeat, opening another data file. Okay, so there's a lot of power in the scripting language here. One perhaps useful function for many of you would be to script the configuration. Imagine our outputs here. Let's, in fact, let's reset everything. Let's go here, reset. Okay, outputs, configure only digital pulses. Right, so I have port 0. Imagine now we have a set of pulses, and there might be 10 of these. We've set the length to be 1 millisecond and a starting frequency of, say, 10 hertz. We're going to need more time, aren't we? Let's go 100 hertz. All right. If you have a setup where you've got lots of outputs that you wish to produce, which means many states that you've got to set up, where you have the same number of pulses, perhaps varying number of pulses, increasing, decreasing number of pulses, but the interval changes, then a script could easily place what I did, the palette icon effectively onto the screen, and simply go through and change the value for each state, that each successive state, increasing or decreasing the frequency as it goes. So it doesn't have to be analysis. Scripting can allow you to, or can speed things up, such as creating these configurations. Okay, I'm aware that we've gone over time. So can I ask if anybody has any burning questions at this point? I can certainly get back to any of you personally on any particular questions. I hope, Sane, that we sorted out the measurements, and please tell me if we haven't. But I think the difference between states or measurements per frame can help you. And I'm reminded yes, the action potential script. So hopefully, Lazani, the action potential script I've just shown you, would that be sufficient, or is there something else that you need? Okay, please get back to me on that. Okay. All right. So do you think there's anything else we should cover? In what way? If you have external equipment with a clock, timing the things on it, yeah. What we want that. Right. Okay. Yes. I've got Simon Parker here for moral support, and he's suggesting mentioning using devices with 2 separate clocks. So we have a clock inside of the 41, of course. We have other devices. Most electronic devices have a clock of some description these days. And these clocks will differ over time. So if we take a 1401 and or 2 1401s and we ran them all day, then we could be looking at as much as a second difference by the end of the day. So we want to synchronize them. We want to use the same clock for both, or at least have a timing pulse provided by one device to another. Okay, so that's it. Right, Sane, thank you very much for your comment, and please email me if you do have any problems. Yufeng, can you post these talks online? Yes, they should all be up there very soon. This is the last one I have to add online, and with luck I'll have it posted sometime tomorrow. And Lazani, the AP script will work, but I would need it to tweak my parameters, etc. If it's okay to email, of course it is. So you can email any one of us really. There's softhelp@cd.co.uk, or if you wanted to email me directly, it's Simon G, or Simon Parker at simonp@cd.co.uk. But anybody here would be more than willing to help. Okay. So I think we can leave it there unless anybody wants to send a very quick message. I don't think there's more activity now. So yeah, I think we'll leave it. So thank you very much for coming along. And if there is anything else, you know where we are. Please contact us. Okay. Thank you very much. Bye-bye.